This is an introduction to the system of equations. There are three different ways to solve a system of equations, which is graphing, substitution, or elimination. But first of all, a system of equations just means we have two equations. And when you are asked to solve it, what you are finding is the place where two or more lines intersect. And the solution will be a coordinate pair, an xy pair, and the point will satisfy both equations. So in order to check your answer, you can plug your solution, your xy pair, into both equations, and if you get a true statement, then you have done it correctly. You found the solution. The solutions can come in three different forms. You can have one solution, which means it's one xy coordinate pair. So there's two parts to that, but it's one solution. And that represents a point where the lines intersect, like this diagram. You could have infinite solutions. Infinite solutions is when the lines actually end up being the same line on top of each other. So every coordinate pair that exists on those lines are shared. So there's an infinite number of coordinate pairs. It's not the same as saying all real numbers. All real numbers is not the solution, but infinite solutions is. And thirdly, you could have no solution. That's because the lines don't intersect. They are parallel. How can you tell if lines are parallel? Well, they have the same slope. If the lines have the same slope, then the lines are parallel. They will never intersect, and therefore there will be no solution or no coordinate pairs that they share. So as I mentioned, there are three different ways to solve. We can graph, we can substitute, or we can eliminate. So I'm going to work through these three examples. First of all, graphing is just graphing. Just do what you know how to do. So I'm going to take this first equation, and I'm going to plot the y-intercept at +4. I'm going to count the slope, which is +3. I can't go up 3, so I'm going to go down 3, 1, 2, 3, and then backwards 1. Let me do that again. Down 3 and backwards 1. So there is my first line. It's a terrible drawing. You should use a straight edge. I just don't have one available. Then the second line is the y-intercept is -3. And the slope is -1/2. So I can go down 1 and to the left 2. Nope, sorry. Down 1 and to the right 2. Or I could go up 1 and to the left 2. And I should see where those two intersect. Right there at that coordinate. So I go ahead and write that coordinate down. It's -2, -2. X comes first, Y comes second. It's always in alphabetical order. So that's the solution. If I want to see if I'm right, I can go ahead and plug -2 into each of my equations. So if I plug in -2 for Y, and I do 3 times -2 plus 4, that does work because that gives me -2 equals -6 plus 4. That would in fact equal -2. If I plug it into the second equation, -2 equal to -1/2 times -2 minus 3. That would give me a +1 minus 3, which does in fact equal -2. So I am correct. The second way that we can solve the equation is by using substitution. So substitution means that I take some expression and I replace it in the other equation. So here I have an equation that is solved for y. So in my second equation, instead of writing y, I could rewrite that expression. When I do that, I will end up with an equation that only has one variable. It has the variable in multiple places, but it's only one variable. So all I did is instead of writing y, I wrote x minus 2. So now I can go ahead and solve. -5x minus 32x plus 8 equals 8. I can end up getting negative 37x by combining the negative 5x and the negative 32x. And then I subtract 8 to the other side, so I have 0. So x equals 0. So that's half of my solution. And then I can plug that, I can substitute it in again to one of the equations. And it doesn't matter which one. I'm going to choose the top one since I'm trying to find y and it's already set up for that. So I plug in 0 for x, and I'll end up getting y equals negative 2. Then I will rewrite it as a coordinate pair. So 0, negative 2 is the solution. Again, I can double check it. I know that it works in that first equation, in the top equation, because I just solved it that way. So I need to check to see if it works in the bottom equation. So I'll plug in 0 for x. I'll plug in negative 2 for y. And let's just see, this is going to equal 0. Negative 4 times negative 2 is positive 8 equals 8. Now we're going to solve with elimination. Elimination usually happens when the lines are in standard form, and you'll see that the x's are stacked up, the y's are stacked up, and the constants are stacked up. And what I'm going to do is I'm going to add or subtract the columns so that I can eliminate one of the variables. In this case, I need to manipulate one of the equations first in order to make something eliminate. The easiest thing that I see, or the quickest thing I see, is if I multiply both sides of this equation by negative 2, then my 16, I'll get 16y and positive 16y, and that'll eliminate. So I'll start by rewriting the top equation just the way that it is. And then I'll multiply the bottom equation by negative 2, so that gives me negative 12x plus 16y equals negative 28. Then I'll add each column. So my green column, then my blue column, then yellow, then blue, then green. So in this case, when I add positive x to negative 12x, I get negative 11x. Negative 16y plus 16y is going to eliminate those. And then positive 17 minus 28 gives me negative 11. Divide by negative 11 on both sides, and I end up with x equals 1. So then I go back to my original problem. I'm going to go to the top, plug in 1 for x, minus 16y equals 17. I'm going to subtract 1, and I get negative 16y equals 16. Divide by negative 16 on both sides, and I end up with negative 1. So my coordinate pair is 1, negative 1. I can go ahead and check that by plugging it into either of the equations to make sure I've done it right.